Hey guys, welcome back to this next video, which is a very important video in terms of a campus network. It allows us the ability to connect the different subnets that we had isolated into different VLANs to each other. So I have the sales department and a marketing department. I want to connect them up to each other. That's what inter-VLAN routing is all about. Basically connecting different VLANs to each other by routing between them, because each VLAN would generally be a different IP subnet. The different topics that will be covered in this particular video. We're going to start with inter-VLAN routing overview. We'll take a look at how to do inter-VLAN routing using a single router with multiple ports, a router with sub-interfaces. This is an interesting one. This is also referred to as router on a stick. This type of configuration. We'll take a look at that. And we'll also take a look at how a switch also now comes with the layer 3 functionality, where it actually can act as a fully functional router. We'll take a look at how to do inter-VLAN routing by using an inbuilt switch inside a inbuilt router inside a switch to do or provide the layer 3 functionality. So let's get started with that. The first thing I want to show you guys is your VLAN concept over here, where I have two different subnets. If you take a look at it, I have a subnet which is the red subnet over here, which is VLAN 10, which is ports E00 and E01 on switch 1. I put these two ports into a single VLAN, VLAN 10. So these two PCs right now can communicate to each other. As you guys can see, they are both on the 192.168 1.0 subnet. And then I have another VLAN over here, which is VLAN 20. These two ports, port E0/2 and port E0/3, are going to be put into VLAN 20. So these two ports now can communicate to each other. So 192.168 2.51 and 2.52, which puts both of them on this subnet. They can talk to each other. And we did something similar to this in the previous video when we labbed up. We actually took it one step further. We had another switch, but the concept was the same. Now what I've done over here is essentially created two isolated VLANs. So I have VLAN 10 over here, which has an IP subnet of 192.168 1.0. It has two PCs connected on it. This is your logical layer 3 network. And I also have another segment, 192.168 2.0/24, which is VLAN 20, and this one has two PCs on them as well, which is PC3 and PC4. This one has PC1 and PC2 on it. So I have these two IP segments. They actually at this point cannot talk to each other because there's no routing happening. These are two different networks, and I need a layer 3 device to accomplish that. And that's what this whole video is all about. What are the different options that I have to connect these different VLANs or different subnets to each other? So VLAN 10, this subnet, VLAN 20, this subnet. I want them to talk to each other. All right, in this particular video, we're not going to do the actual configuration part of it. We're going to talk about it, and then in the next video, I'm going to actually implement it. But one of the underlying things of this particular video, and which also is the same thing in the next video, is the aspect of physical switch or physical network, which is this depiction where the physical ports are connected to, versus your logical network, which is your layer 3 network, which I had just drawn moments ago, which I cleared up. And you'll see that as we go through this video, a lot of that implementation, as I take this particular diagram and convert it or map it over to a logical diagram, how that looks. And that's basically the actual flow of traffic is going to be based on the logical network, also known as a layer 3 network. So let's get into it. First thing, the routing, inter-VLAN routing overview. What is it all about? In the network diagram in the previous slide, we have two PCs assigned to VLAN 10 and two PCs in VLAN 20. We saw that. Although the PCs can talk within the VLAN because they're in the same VLAN, same network, they will be able to talk to each other, but they will not be able to talk to other PCs in the other VLANs, because in order to connect from one network to the other network, the device that allows me the ability to do that is your router. And I don't have a router right now. So inter-VLAN routing will allow us the capability to route between the two networks. Two different ways of doing it. You can either use a physical external router to do it, and even with this you have two options, either using multiple ports as a single port, or you can use a layer 3 switch. It is basically a switch that has routing capabilities built in. A layer 3 switch is a switch basically which has the ability to perform routing functionalities. As I said, we'll be taking a look at both those options as we go through this particular video. Pay attention, guys. This is a very important aspect of networking. This is your foundation networking, which will help you not only in route switch, but it'll help you with any field that you go into in terms of routing. Whether it's security, whether it's data center, this stuff is going to set your foundation on which you build your other fields or other how should I say it, other networking aspects on top of. All right, so first things first, let's take a look at an example where I'm going to connect two VLANs to each other using a router with two interfaces. So what I want to do now is, we've already discussed that these red ports cannot talk to the green ports. Why? They're in two different subnets. So my diagram right now is a green subnet like that. You have a red subnet like that, which is logically broken down into two different VLANs, two different networks based on the VLANs. Now what I want to do is I want to connect the green to the red, this IP subnet to this IP subnet, and I want to be color coordinated as well. All right, the way I'm going to do that is I am going to put a router in the middle, which is going to have one port which is connecting into VLAN 10 on that particular subnet. Let's say it's .1 on that particular network. This is 51, 52. I'm going to put the interface, one of the interfaces on router 1, which is connected to VLAN 10 as 1.1, 192.168.1.1. These PCs will use a default gateway now as 192.168.1.1, telling it, hey, listen, if you want to go out, go through R1. We've already discussed how networking works, how a packet changes its layer 2 and layer 2 headers as it goes from one network to the other. That's the aspect that comes in. Remember that thing about ARPing for the default gateway? That's what I'm talking about over here. At the same time, I'm going to take the second interface from the router and put it into VLAN 20 over here. So now these guys will use him as well as the default gateway 2.1. So 2.0 network, and this guy becomes 2.1. So for these PCs over here, which is 3 and 4, their default gateway for the two network 251, 252, their default gateway will be this guy, which will be 192. Where should I write it? 192.168. 2.1, which is going to be the default gateway for these PCs over here. And by doing that, they will be able to communicate to each other. How do I go about doing it? Very simple. Just by assigning ports to the appropriate VLANs. I had already gone in and assigned E00 and E01 to VLAN 10. How did I accomplish that? I'd gone into my switch. In this case, if you look at this physical topology, I would have gone in and said interface range, and I would have put in E0/0-1, so 00 and 01, and I would have done switch port mode access and switch port access VLAN 10 over here. All right, so that would have put these two ports into VLAN 10. Now what I want to do is I also want this port over here to be part of the same VLAN. Why? So that it can communicate to the router, so that these PCs that I have, which PCs? The PCs that I have over here, PC1 and PC2, can communicate to router 1 as the default gateway. So also on the same switch, now I'm going to say interface, and I could have done it in the same range if I knew. E1/0, this port of the switch should be also in the same VLAN. Switch port mode access, switch port access VLAN 10. So now these three ports on the switch belong to the same VLAN. So PC1, PC2 and router 1 can communicate to each other. So now I can use him as my default gateway to communicate to other networks. All right. And at the same time, what do I need to do for the green VLAN? Basically the same thing. I would need to put these two ports by using the same command, switch port mode access, just for different ports. I would do it for the green part. I would do it for what ports? E02 and E03. So E02 and 3, and I would put them into VLAN 20. So that would put these two ports in VLAN 20, and I want them to communicate to the router port so it can go to the other side. So over here, I would change this guy to VLAN 20, and this port over here would be port 1, this port over here. So E11, E00, E02, and E03 will be in the same VLAN. E00, E01, and E10 will be in the same VLAN. Now what do I do on the router? I configure this interface and the appropriate subnets, 192.168.1.1, and this would be 192.168.2.1. And I have inter-VLAN routing between the two different IP subnets. Logically speaking, now what I've done is this. I have two subnets now, 192.168.1.0, 192.168.2.0, and what I've done is connected these two segments using a router by putting a router port, two router ports, one port into VLAN 10 and one port into VLAN 20, and connecting them to each other. But if you take a look at it, the router now has two ports, E00 and E01, connected to the same switch, but two different ports on the switch and two different VLANs. So this port, E00, has connectivity to PC1 and PC2. This port, E11, has connectivity to PC3, PC4, because they all belong to the same VLAN over here, and these guys belong to the same VLAN over here. All right, so let's take a look at the write-up. Hope you guys understand this. So let's take a look at the write-up over here. In this configuration, we use a router with two ports and connect the two ports to two ports on the switch, which I showed you guys. We configure each port to be part of the two VLANs. This allows the PCs in VLAN 10 to communicate at the router port. The router will route between the two VLANs. Now the logical diagram is this. So this is your physical diagram. This is how the cables are done. But logically, what I've been drawing to you guys, and this is what the flow is going to be looking like, is going to be like this. So in a layer 3 diagram, this is a typical layer 3 diagram that you'll see in the industry. Again, as I said, it's a logical network diagram. Option 1, which is a router with two interfaces. You'll see the router interfaces that are connected to VLAN 10 and VLAN 20. You don't see switches over here. On this diagram, you don't see a switch because switch is a physical topology. And you have the two PCs over here, two PCs over here. For them to talk to each other, they go through the router. All right, so that's one way of doing it. So again, physical to logical, this is what the physical looks like right over here. So physically, the cables are done like that, and once I put the ports in the appropriate VLAN, the logical diagram will look like this. And you need to get good at this, because this is, you'll be given this as well as this diagram, say, hey, this is your physical diagram. I want my traffic to be forwarded based on this logical diagram. So all you got to do is go into the ports, the appropriate switch ports, put them into the appropriate VLANs so that the logical diagram, which is this guy, gets created. All right, good. So the next thing that I want to take a look at, do the same thing, but do it in a more efficient manner in terms of the ports on the switch, on the router. So the other way of doing it, and this is a little tricky the first time you see it, but it's very efficient in terms of the router port. Sometimes you don't have multiple ports on the router to be able to do this, where you want to do inter-VLAN routing, you want two ports. You might have a router which only has one open port. So I want to accomplish the same thing. But the way I want to do that is by using a single router port to be able to route between VLAN 10 over here and VLAN 20 over here. But the problem is, unlike the previous example where I had one interface of a router in VLAN 10, another interface in VLAN 20, and route between the two interfaces, in this example, my router only has one available port. So that's where sub-interfaces come in. What are sub-interfaces? On a router, a sub-interface is a logical interface which ties up to ties up this interface, this logical interface, to a particular VLAN. So when I create E00.1, I will say when a packet comes in into my router, which is part of VLAN 10, I will assign or forward the traffic to E00.1. But if the traffic comes in with the VLAN tag of 20, I want that traffic to be going to E00, it's the same physical interface, .1. I want 20 to go to E00.2. All right, so I associate VLANs with the sub interfaces. So that allows me the ability to use a single switch interface connecting to a single router interface, but be able to segregate the traffic that needs to go into these two logical interfaces on the router by use of VLAN. So when a packet comes in from switch 1, from PC 1, it would have entered into E00. The switch would have tagged it with VLAN tag of 10. When the switch forwards the traffic to the router, I want that tag to be maintained so that when it hits E00.1, it sees VLAN 10 and says, oh, this traffic is for E00.1. It won't hit E00.1, it would have hit E00, but E00 would look at the VLAN tag of 10 and forward the traffic over there. So the key thing over here that is very important to understand, and that's something that you should pick up immediately. In order for the switch to maintain the VLAN tag, so when the frame came into the switch tagged it with the VLAN tag of 10. When I send it to the router, because the router has configured the sub interface based on a classification of the VLAN, the switch needs to maintain the VLAN tag when it sends it to this router running a sub interface. In order to do that, this port on the switch needs to be a trunk port. Why a trunk port? Because if you guys remember in one of the previous videos, I talked about the characteristic of a trunk port. What's a characteristic of a trunk port? A trunk port does not touch or change the VLAN tag. If it was an access port, I can only put this port part of one access VLAN. I need it to be able to carry traffic for two VLANs, 10 and 20, and maintain the tag. So it will maintain the tag. So when I maintain the tag over here, this gives me the capability of doing what? This gives me the capability of sending the frame to router 1 based on the VLAN tag. So the frame would have gone into router 1 as 10, 192, 168, 1.51, wherever it's going. But the main thing is it has VLAN tag 10 on it when router 1 receives it. On router 1, I would have created E0/0.1 with the VLAN associate of 10. I'll show you how to do that. And then the IP address of 192, 168, 1.1. So I'm not going to use two interfaces. I'm going to use a single interface on router 1. So in reality, the frame is received by E01. E01 does not know who the frame belongs to, but it looks at the VLAN tag because the trunk port configuration over here would have maintained that VLAN tag. It sees VLAN tag of 10 and says, oh, VLAN tag of 10 is associated with E00.1. All right, versus if the frame had come in from this guy over here, it would have set the VLAN tag as 20. And similarly, you would have created E00.2 with the VLAN tag of 20. I'll show you how to do that in a bit. So this address would have been 192.168.2.1. So VLAN tag 20 is the one that will allow E00 to forward the traffic to E02. And if it was with a VLAN tag of 10, it would forward the traffic to E00.1. All right, so that's how you do this. And if you take a look at this diagram, you also see that it's called a single interface connecting to the switch. Hence the word, the term that has been coined for it. What is that? Router on a stick. Good so far? So let's take a look at the slide for it and also the configuration for the router. How do you configure the router interface with a sub interface? So in this configuration, we use a router with a single port, router on a stick. We split the port into two logical interfaces on the router. What are these logical interfaces called? These logical interfaces that are based on VLANs are called sub interfaces. We assign each sub interface to a VLAN corresponding to the VLAN that is on the switch, and basically that sub interface will always process traffic for that particular VLAN. The switch needs to send the VLAN tag to the router for it to recognize the packet coming in from a specific VLAN and forward to the appropriate sub interface. We talked about that. For maintaining the VLAN tag on the packet, we do need to configure the switch port on the switch as a trunk. All right. So one of the things, I want you guys to remember this statement, and I want it to stick with you. And what is that statement? Whenever you see a sub interface on a logical diagram, the corresponding port on the switch is always going to be a trunk port, okay, to maintain the tag. So what I'm saying over here is, let me show you a logical diagram for this, which will eventually happen. If you see a logical diagram like that, and you see that over here, it's E00.1, E00.2. So wherever this E00 interface is, that interface on the switch interface will be a trunk. So anytime you see a sub interface on a router, the corresponding switch port is a trunk, has to be a trunk, so that it can send you the frame with the VLAN tag intact, so I can segregate the traffic. So don't forget that. And the same thing over here on the physical diagram. If you take a look at the physical diagram as well, although I put the sub interfaces over here, generally on the physical diagram you would not have seen this. So you would have seen it like this. Just like that. So you would know if it is a trunk or a access port. So you would need to take a look at the logical diagram. Oh, E00 is a sub interface on the logical diagram. So this interface needs to be configured as a trunk. All right. And I've given you the configuration for that as well. So we're on the last bullet over here. Whenever you see a sub interface on a logical diagram, the corresponding port on the switch is going to be a trunk port to maintain the VLAN tag. This is the configuration. On the switch side, this interface E1/0 is a trunk, and I'm using encapsulation of .1q, switch port mode trunk. Now, if I want, because I know in my case on this port, there's only 2 VLANs that will be sent. This is not a normal trunk between 2 switches. This is a trunk between a router and a switch. So in this particular example, I just have 2 VLANs that are in my topology, which are VLANs 10 and 20. So what I could technically do over here, if I wanted to, and to make it more efficient, I don't want traffic for the other VLANs to go over this, I could say switch port trunk allowed VLAN 10, 20. So that would not allow other traffic to go over this trunk, which generally is the case between 2 switches. So this is what you would do on the switch anytime you see a corresponding device port as a sub interface. Now, what do you do on the router to support this? On the router, you do a no shut. You only need to do the no shut on the physical interface. Okay, but you don't assign any IP addresses under E00. What you do instead is you create a sub interface. And how do I create a sub interface? E00, the same physical interface, and your .1 is your, I'll put it in perspective. So this is your physical interface. This is your .1, which is your sub interface. And the sub interface will always be associated with the particular VLAN, saying encapsulation .1q, which is matching the encapsulation on the other router. And the VLAN that I'm using for E00.1 is VLAN 10. Because it's in VLAN 10, I'm going to put the IP address that matches VLAN 10's IP scheme. This becomes the default gateway for all the different PCs. Later on in the next video, I'll actually lab it up so you guys can see it. Similarly, what have I done over here? E00 is my same physical interface, but I've created a sub interface, .2, and .2 is associated with VLAN, and this should have been, this should have been over here, VLAN 20. And that 20 is associated with what? So this 20 is associated with your VLAN 20, and this is the corresponding IP address. All right, and this guy over here, same physical interface, but it is .1, which is part of VLAN 20, or sorry 10, and this is the IP subnet. So that's how you create your sub interfaces on the router to support a router on a stick, single port having multiple sub interfaces. And this is what the logical topology looks like now, which I showed you up front because I want you guys to see it. So E00.1, E00.2. So now you need to know that E00 on the router, the physical interface, whichever switch it connects to, this port on the switch needs to be a trunk. Nowadays, though, what they do is rather than using an external router, what the companies are doing for inter-VLAN routing, they're buying switches that have built-in routing capabilities. These switches that have built-in routing capabilities are known as layer 3 switches. All right, so this is what a layer 3 switch will look like. You would have a single switch which has layer 3 capabilities. So you have a virtual router which is inside the switch. You don't need to have an external router. Now this virtual router, what interfaces does it have? I will create a switch virtual interface which belongs to VLAN 10, another switch virtual interface which belongs to VLAN 20. So, and I'll assign IP addresses to these virtual interfaces which are within the switch. And those ports, when I create that switch virtual interface, the SVI, the way I create that is saying interface VLAN 10. All right. As soon as I say 10, it knows that it is a port, a logical port, a virtual port that belongs to VLAN 10. And then I would give it an IP address of 192.168, let's say 1.1. So this virtual interface, the switch virtual interface, the V is for virtual interface, is part of VLAN 10. And similarly, on the switch, I would create another SVI for VLAN 20, interface VLAN 20, and assign it the IP address from the 192.168.2 subnet so that it can act as a router port for VLAN 20, and it will route between the two as if it is a internal built-in router. So the router over here is within the switch. So this is something that comes built in with the switch as a capability of the switch. These switches will be more expensive than a normal switch. So let's talk about it now. Let's take a look at what the slides have to say about it. In this configuration, we'll use an internal layer 3 capability of a switch to route between VLANs. So you need to see if that switch is capable of doing that. In order to configure inter-VLAN routing on a layer 3 switch, you need to enable the IP routing capabilities. On a router, this is also there, but this is a default characteristic of a router. On every router, this command is on by default. Here I need to do it because on a Cisco switch, a layer 3 switch, even if it's a layer 3 switch, this capability is not on by default. Once it's done, I need to create the layer 3 logical interfaces, which are your router interfaces. These interfaces are called the switch virtual interfaces, SVIs. All right. The IP address of the SVI becomes the default gateway for the devices for the VLANs that are inside it. Now, how do I do it? Very simple config. First thing, I would turn on the routing capability of the switch that says, oh, it has layer 3 capabilities. Then I'll create the two SVIs, one for VLAN 10 with the IP address that is going to be the default gateway for all the devices within that VLAN, and then another SVI for what? 20. Got it? The logical diagram. Now, same thing. Now you'll notice over here, it's a layer 3 switch. And it's got an SVI, which is in VLAN 10, another SVI in VLAN 20 for these PCs. That's your inter-VLAN routing using that methodology. So to recap, what are the different ways I've shown you that I can connect the different VLANs to each other? The first way was using a router with multiple interfaces. one interface going into one VLAN, another interface going to another VLAN. The other one, router with a single interface. This is the sub interfaces. This is also the one that I called a router on a stick configuration. And the third way was using an L3 switch, which it's a switch with layer 3 functionalities in there. Nowadays, the most common implementation of inter-VLAN routing is a layer 3 switch. That's within uCampus. All right. In the next video, we're going to take it one step further. We'll actually implement this. We'll actually lab it up. Not only that, in that, I'll give you a physical diagram which will include the capability of doing a router on a stick. We'll do the capability doing router with two interfaces, and we'll do a layer 3 configuration on that as well. So do join in. That is a very important video. That is basically the video that I actually demo the physical to the logical setup and the steps that you need to do to accomplish that, because the first time you look at it, it is a little complicated, a little daunting to take a look at the two topologies and try to map it over. Thanks for watching. See you in the next video.